So hopefully by now you tried to figure out some sort of pattern with the logs that you saw in question number 2. In this video, we'll attempt to explain the pattern for those of us who didn't figure it out. If you did figure it out, skip this video and go on to question number 4. But if you didn't figure it out, this would hopefully give you something to think about. Remember how in the previous video I mentioned that a log is related as an inverse to an exponential? Keep that word exponential in mind. Exponential is a derivation of the word exponent. And if you think about exponents, there is a pretty distinct way of turning a 2 and an 8 and a 3 into related numbers. Namely, the fact that 2 to the power of 3 would give you 8 as an answer. In other words, if I focus on the pattern that I can see here with these numbers, 2 to the power of 3 would give me 8 as a result. And I'm purposely drawing that pink arrow so you can see the order in which I just thought about those numbers, because that order actually works for all of the log expressions that you see. In other words, if I look at the second one, I can use the exact same little curvy arrow to hopefully visually link the 3 numbers together in the order that makes sense. 3 as a base to the power of 3 as an exponent equals 27 as a result. In the next one, the same pattern works there too. And again, I'll recreate this little visual pattern here. We would have 5 as a base to the power of 2 as an exponent equals 25 as a result. And then of course in the last one it works there as well. 10 as a base to the power of 4 as an exponent equals 10,000 as a result. So it is clear that there is an exponential pattern kind of hiding within each log expression. And now that you recognize that a log is simply an exponential in disguise, hopefully you can start to fill in some of these blanks. Now that pink arrow that I drew may help to kind of fill in the blanks if you're looking at some of the problems down below. So you may want to keep recreating this pink curvy arrow, because I'll definitely use that often to help recreate the order in which that exponential expression needs to develop. The exponential expression always needs to start with a base, and that base is always the subscript that you'll see attached to the log. So this one will have a base of 2 to the power of whatever's after the equal sign, whatever's on the opposite side of the problem. That's the part that is apparently unknown to us, so I'll draw a little box there. Then we say that the result of 2 to the power of whatever is equal to the number that was originally attached to the log expression, the 4 in this case. So when I think about this exponential expression, I have something that's a lot easier to process. 2 to the power of something is 4. Oh, well, that's pretty visually obvious. We know that 2 to the power of 2 must be 4. So the missing number that goes in the box must be 2, because we can think of it exponentially, and all of a sudden the number in the box makes more sense. So the key is recognizing that a log is just an exponential in disguise. And if you think about that logic, hopefully it'll open up quite a few of these problems by allowing you to look at them not as new log expressions, but as old school exponential expressions. In the next one to the right, we could do the same exact arrow, and we can process the information in the same order. We would have base of 2, always the base to start us off is the subscript of the exponent, or subscript of the log, sorry. So 2 to the power of whatever's on the opposite side of the problem. So in this case, power of box, we don't know, equals, as a result, whatever number is in the center of the expression, or the number that was attached to the log and its subscript. That's the 32. So if I look at that now, I have 2 to the power of something that would give me 32 as an answer. Well, I can just think about basic properties of exponents, and I know that 2 to the power of 5 would do the trick. So it must be a 5 in that missing box. So you'll notice it's kind of hard to use the box and the log expression to figure out the answer, but as soon as you translate this expression to an exponential expression, then it becomes a bit more familiar. Then our algebra instincts kick in, because we've done enough with exponents now to know or have a good sense of how they behave. So the key here is translating every log into an exponential expression. Let's try the next one. The box is missing, and that's usually the base that we start with. So we have something to the power of 2 would equal 100. Notice my little pattern there. And if I recreate it, I have something, unknown, box, to the power of 2, remember the power is always the number on the opposite side of the log problem, equals the number attached to the log itself, which is 100. So I'm saying something squared must have to be 100, and if I think about that, I can say to myself confidently, oh, well, the box must be 10, because 10 squared is 100. Notice the box itself is the subscript, so I had to write that 10 a little bit smaller than before. This is the last one I'll do, and hopefully then you can try a few on your own. Let's try this one. 5 to the power of 3 equals whatever's in the box. So I start with the subscript 5, raise it to the power of whatever's on the opposite side of the log expression, and equal it to whatever's attached to the original log expression. So I would say to myself, okay, 5 to the power of 3 is something. That's a nice mental math exercise. 5 times 5 times 5 would be 125, so we know that 125 goes in the box. If you can start to do this without rewriting it, that's great. If you can start to do it in your head, that's wonderful. But at this point, hopefully now you've seen enough of the pattern that you can try the second row of problems in this log section. Also, when you finish doing those problems and the pattern starts to make a little bit more sense, try in question number 3 to illustrate or describe the pattern in your own words. You can borrow from my words and phrasing, of course, and you can certainly borrow influence from the answer key that you'll see posted in the learning plan, but try to create some sort of visual for yourself so that you can start to think about, in your own words or phrases, how this pattern is going to make sense to you. What are the steps going to sound like in your head when you look at a log expression and try to rewrite it as an exponential? Hopefully once you get those steps down, you'll be able to look at question number 4 and feel confident that we understand where this is going.